Welcome to this session in which we'll talk about the developer product ArcGIS Runtime SDK for .NET. Here we'll be specifically talking about using the SDK for building apps for Windows, but remember this is an SDK that contains .NET APIs for Windows, Android and iOS. So many of the concepts that we'll talk about in this session are applicable across these platforms. My name is Mike Branscombe. I'm a product engineer on the ArcGIS Runtime SDK for .NET team. I'm joined by my colleague Morten Nielsen.
Yeah, that's me, and I work as a development lead for the Runtime SDK for .NET.
And we'll be taking you through the session today. So our agenda for the session then is to look at an overview of the ArcGIS Runtime SDK for .NET. We'll introduce the ArcGIS Runtime Architecture, and that helps you understand how the API is built and the ways in which you work with it. We'll show you several of the key resources you'll use when getting started with the SDK, and we'll look at both enhancements that we've made specifically to the .NET SDK, but also an enhancement that we've made more broadly across the ArcGIS Runtime over the last year since the last Dev Summit, in our support for Dotnet Core and advanced Symbology, Toolkit and performance. And finally, we'll wrap up with a look at what we'll be working on throughout 2020. Okay, so first up, we'll take a look at an overview of the ArcGIS Runtime SDK for .NET. So, ArcGIS Runtime SDK for .NET is a collection of .NET APIs and SDK resources that enable you to build native apps with mapping and location analysis capabilities. The apps you build can include rich 2D and 3D visualization. ArcGIS Runtime provides access to ready-to-use maps and data. They can come from ArcGIS Online with base maps, elevation, imagery, feature data, and more. The API includes functionality for searching data and to retrieve features and also geocoding to find addresses and using their location, so powerful search and geocoding capabilities. In the applications you build, you can also perform analysis on transportation networks for routing and network analysis, including finding the closest facility or finding the service area of a specific facility or facilities. With ArcGIS Runtime, you can access demographic data layers coming from ArcGIS Online, and you can integrate them with your data. The API supports advanced spatial analysis operations. You can use the software or platform as a service concept to have your data hosted in the cloud with ArcGIS. And crucially, ArcGIS Runtime provides great support for offline workflows where your application will be used in environments without any network, where they're disconnected. So that was an overview of the capabilities of ArcGIS Runtime SDK for .NET. Let's spend a moment just thinking about why you would use ArcGIS Runtime. So ArcGIS Runtime is intended for building native apps for popular platforms and devices today. You can build standalone map-centric applications, and you can integrate GIS into your line of business applications. One of the key benefits of ArcGIS Runtime is building these native apps that allow you to match the user interface and user experience conventions of the platform that you target. For example, Windows, Android, or iOS, as we see the screenshot there. You also have access to the native device capabilities such as GPS or other sensors. Of course, you can be connected to ArcGIS Online or your ArcGIS Enterprise, but also ArcGIS Runtime provides support for being offline or disconnected from the network and using local data on the device. And you can also build applications with ArcGIS Runtime that you distribute through an app store as well. So some of these items here that I've covered differentiate the reason why you would use ArcGIS Runtime from other APIs that Esri provide, such as the ArcGIS API for JavaScript, which is intended for web applications, and the ArcGIS SDK for ArcGIS Pro, which is a .NET SDK, but that's specifically for customizing ArcGIS Pro. So ArcGIS Runtime SDK for .NET then is about building native apps. Let's dive into a bit more detail about the SDK itself then. So ArcGIS SDK for .NET includes multiple APIs. Includes APIs for building applications for Windows desktops with WPF or Windows Presentation Foundation. And the important note to call out here is it supports both Dotnet Framework and Dotnet Core 3.1. You can also build applications using the Universal Windows Platform APIs, and also you can build applications for Android and iOS with the Xamarin APIs. We also support Xamarin Forms, allowing you to build more cross-platform abstracted applications for Android, iOS, and UWP. And of course, as well as the APIs, I've talked about how this is an SDK. We provide great SDK resources to make you more productive as a developer. That includes IDE integration with project templates in Visual Studio, a toolkit with a set of toolkit controls and components, documentation, both guide, concept documentation, and also API reference. We provide sample code and then building up through tutorials to help you get started quickly, right through to fully fledged open source apps. And one of the highlights of the ArcGIS Runtime SDK for .NET is because we provide support for multiple APIs and multiple platforms, you can share your .NET C# business logic across Android, iOS, and Windows. Okay, so after we've taken a look at an overview, now let's dive into a bit more detail about the architecture of ArcGIS Runtime. So what I'd like to do on this slide is really provide you with an understanding of the context of the overall ArcGIS Runtime architecture and how the .NET SDK fits in. We build ArcGIS Runtime functionality such as rendering, data access, analysis, layers, maps, symbols in a C++ library that we refer to as the Runtime Core. It's architected and built to support multiple architectures, so 32-bit or x86, 64-bit or x64, and also ARM64 as well. We currently have a long-running project underway to support the new generation of rendering APIs as well, with an active project working on support for Metal for iOS. The resulting library in each case is then built for specific platforms, so Android, iOS, Linux, macOS, UWP, and Win32 as well. So that's the ArcGIS Runtime Core, and then we wrap that Runtime Core in specific SDKs that provide you with a public API that you code against in the environment that you would expect. One of the key things to emphasize about this is that if you're working, for example, with the .NET API and you're targeting Android, iOS, UWP, that is essentially the same logic that's running in that Runtime Core, but exposed through the different platforms. Let's focus in on the .NET SDK then. So I've talked about a number of the platforms that we support: Android, iOS, UWP, and Windows. And that means we're building or compiling the Runtime Core for 32-bit, 64-bit, and also ARM64, and both for DirectX and OpenGL rendering pipelines. And then on top of that Runtime Core, we expose that capability through to you via .NET APIs. So those are for Android, iOS, UWP, and WPF. And then Xamarin Forms builds on top of the Android, iOS, and UWP APIs to provide that abstraction layer for you. Okay. So we've talked about an overview of the SDK and also taken a look at a bit more detail about the architecture of the SDK. So how do you get started with the ArcGIS Runtime SDK for .NET? Well, it's provided to you as a Visual Studio extension or a V6, and you can install that directly into Visual Studio through the Manage Extensions dialog. You can search the extensions that are available online. You'll find the ArcGIS Runtime SDK for .NET, install that directly into Visual Studio, and that provides you with project templates for each of the supported platforms. Those project templates reference the API via NuGet packages that are hosted on NuGet.org. You can also download the Visual Studio extension from the developers website, ArcGIS developers website, and it contains the same project templates for each supported platform, But the difference between the two extensions is that the one you download from the ArcGIS developers website actually contains the NuGet packages and will create a local NuGet repo for you for offline development. So the NuGet packages that are hosted on NuGet.org are the WPF API, UWP, Xamarin Android, Xamarin iOS, Xamarin Forms, which has a dependency on the previous NuGet packages, Android, iOS, and UWP. We also published the ArcGIS Runtime SDK for .NET Toolkit NuGet package on NuGet.org and the Augmented Reality Toolkit NuGet package as well. Okay, so we've talked about an overview of the APIs that are included. Let's take a look a bit further at getting started. So here I am within Visual Studio, and I'll go to the Extensions menu, the Manage Extensions option, and I'll search. It's retrieved the list of extensions that are online, and if I search for Esri, this is actually searching the Visual Studio Marketplace, and it's returned some of the key, some of the extensions that I already have installed. So we can see I have the ArcGIS Runtime SDK for .NET Augmented Reality Templates extension, and also ArcGIS Runtime SDK for .NET Templates extension. So you can see with that green check mark, I've actually already got this installed, but I could install that directly now. Going through to create a new project, then we'll see the project templates that are available, and I can filter these by different categories. So first I want to filter by ArcGIS, and then because we're specifically talking about Windows in this session, I've also filtered by Windows, and we can see the 3 project templates that are included with the SDK that allow me to target Windows specifically. So that's WPF with .NET Core, WPF with .NET Framework, and Universal Windows Platform. I'm going to pick the WPF for .NET Core project template and then just create a brand new application. We'll let Visual Studio just open up that template, and we'll see within the Solution Explorer that initially there's a little exclamation mark next to the dependencies, and it's just resolving those now. So it's resolved the Esri ArcGIS Runtime WPF API, and it's resolved the extensions to .NET Core and .NET Core for Windows desktop apps. Taking a look at what's contained within the template, then in the main window XAML, we can see that we have a simple framework for an application here, but it's using a map view model that contains the map, and we're binding to that. If we take a look at the map view model, then we can see the instantiation of that, and that it'll return our map to allow the window to bind to that. If I just run the application, we'll see that it contains, at this point, just the streets vector base map. So a simple application, basic MVVM framework in the template, but a great point to get started as you start your development. The next place I would always go to think about getting started is the ArcGIS for Developers site. If we take a look under the documentation, we can see here ArcGIS Runtime SDK for .NET. And this site you should really think about as your starting point for development. Many resources are available here for you through getting started, but also ongoing in your development as a reference for you to come back to. So if we go to the Getting Started item here, we can see a number of tutorials that are available for you. And here's a really nice set of 10 to 15 minutes, maybe up to 25 minutes for the new augmented reality tutorial that we added recently. And these provide an overview of many of the common workflows that you'll go through when working with the API. Other content that's available on the ArcGIS for Developers site are the guide. So this provides you with conceptual information about how you work with the SDK and the workflows that you'll go through and how the SDK interacts with the rest of the ArcGIS platform. The API reference is available for you for each of the supported platforms. And the sample code tab provides you with a description and the ability to view the sample code, but also links to the sample code that we publish in a public GitHub repo. There's also a link here to the sample viewer itself, and that will jump out to the sample viewer that's actually within the Microsoft Store, and we can download and install that. If I go to the Store application and just search Esri, we can see the ArcGIS Runtime SDK for .NET samples here, and we can download the compiled sample application, or I just launch it because it knows I've already got it installed. So launching the sample application then, this is the sample viewer for the WPF API, but essentially the same samples are available to you across all of the APIs supported with the SDK. If we take a look at one of the specific samples then, the distance measurement sample, and you can see 3D data coming in here. This is a really nice 3D analysis sample. You can see it allows me to measure distances in 3D. Now, there's many samples contained within here, but what I want to highlight within this specific sample, and it's the same pattern for all those samples, is there's a nice description which tells you about the use case that this sample solves, how to use the sample and relevant API types, and also the source code. So I can view the source code here within the sample viewer and explore all of the samples that are available to me. This source code is essentially the same source code that's within the public GitHub repo. And then finally, the one last thing to highlight is just the support tab within the developers site, and that contains links to discussions on GIS NET and also other avenues for support when working with the SDK. So one thing to mention, included on the ArcGIS for Developers site in that .NET SDK area are the system requirements for your development. When you're installing Visual Studio, one of the things you'll want to make sure is that you have the right workloads installed. So these depend on the applications you plan to build, but when installing for the first time, hey, why not just install every option you have? And for the working with the .NET SDK, that would be .NET Desktop Development, allowing you to build WPF apps. The Universal Windows Platform Development workload for UWP apps, mobile development with .NET, so that allows you to target the Xamarin APIs, and then .NET Core cross-platform development as well. So installing those 4 workloads would allow you to build apps for all of the supported platforms that the ArcGIS Runtime SDK for .NET supports. Okay, so we've talked about an overview, the architecture, getting started. Now we really want to dive into some of the enhancements that we've made to the SDK over the last year. So first up is a look at the Toolkit. The Toolkit's a really popular component that many of our users like to work with. It's been released, we've had successive releases in parallel with releases of the API, but we had a major release of the Toolkit just in February this year, the 107 release, and some of the highlights that were included with that are support for .NET Core with WPF. So in parallel with our support for .NET Core with WPF in the API, we enhanced the Toolkit for that. We added a new bookmarks control, so in building out the functionality within the Toolkit with that new bookmarks control. We actually undertook a complete rewrite of the legend control and also the table of contents control that's currently in preview. We added support for dark mode on iOS, and we added a new DocFX-based website with API reference and concept documentation. So this was in response to direct feedback from you, our users, that you wanted additional documentation about the Toolkit, and we'll take a look at that in a second. Over time, we're planning to migrate that same content to the ArcGIS for Developers website, but because it was based on your feedback, we wanted to provide that content to you as quickly as we could in the best way we could. We also, as part of the Toolkit, we enhanced and provided an augmented reality toolkit. So that's a separate extension. When I initially looked in Visual Studio at these extensions that are available in the Visual Studio Marketplace, there were 2. One was the ArcGIS Runtime SDK for .NET templates, and then there was a similar extension, but specifically including the augmented reality templates. Okay, so let's dive out and just take a quick look at that documentation website on the Toolkit. So this is the Toolkit repo, public within the Esri organization on GitHub. And we can see here there's a nice link at the top, which would let me jump straight to the documentation. and there's other links provided within the README there. If I go straight to the documentation, here's the DocFX-based website. And one of the things you might want to do is look at the API reference. And if we, for example, look at the Dotnet Core API reference, and I'll drill down into one of the controls. So perhaps I'll choose the new bookmarks view control that we just added. Here we can see the API reference for this control. One of the really nice aspects about this documentation that we're really excited about is the fact that over here on the right-hand side, there's two links. One is view source. And if I click that view source link, that actually jumps straight to the specific line in the source code in this public GitHub repo for the source code for the bookmarks view. If I spotted a problem in the documentation, I wanted to provide some feedback, I could click improve this doc, and actually that would start a new PR with a proposed change or a proposed update to the documentation. So you could actually help us contribute to the documentation. Okay, so that was an overview of the toolkit enhancements that we've made. Now let's move on to look at performance.
So in the past year, we spent a lot of time on really trying to focus on the performance of the runtime for .NET, and so we've seen actually some huge improvements over time, and we kind of want to share a little bit about what we've been working on. We especially looked at like key features that was causing performance issues for people, like when they want to work with hundreds and thousands of features and try and squeeze as much performance and memory reduction out of it as possible. Especially when we're working with something like .NET that has a garbage collector, it's quite important that we don't actually allocate too much, because it just gives the garbage collector more work to do, and every time it needs to clean up, it actually stops all processes. And while they typically only take milliseconds, they can kind of affect your performance of your app. So we have some graphs that I kind of want to just share to give you an idea of like the improvements we've been doing over the last few years. And so here's just a set of graphs and working with graphics. And what you're looking at is that the green bars represents execution time as a relative value. So 1 means basically what the reference, like the first release, and then the light green ones are allocation. So if it's lower than 1, that means it's faster for the green one, or less memory allocations for the light green one. And for instance, a value of 0.5, I mean, it's twice as fast or half the memory. And so you can generally see, like over time, especially in the last few releases, these values really start dropping down. Like getting attributes is more efficient, memory is going down. And you see a few numbers here, even for update 8 that we haven't even shipped yet. So these are preliminary numbers. We actually have some stuff in progress that might improve these even more. So we're very excited about these. We have another example here of just working with geometry. And you can, for instance, see like how creating points went down pretty quick in the early on, and now also allocations for creating a point has gone down by around 60%. You would even see something like in the first chart, you actually see that it looks like there's a whole bar missing with update 8, but it's actually because we went completely allocation free. So there's no memory allocation for setting a graphics geometry, apart from, of course, creating the geometry. Same thing for spatial reference. It also looks like charts are missing, but what we did was made it 400 times faster. So the bar is not even visible here, and it's also went completely allocation free. So while this was a very, very, very fast operation already, it does have a small impact across the board for anything that was working with geometry and needed spatial references. Just here's another example of querying feature tables. Again, querying lots and lots of features. We again reduced memory, increased performance by a good 60%. Or adding 40,000 features was kind of extreme, but not uncommon. Again, we have made this about twice as fast, and the memory consumption is just going down as well. Here's an interesting one, like just pure map startup time. Like how long does it take from you add your map tree view to it's actually presented on the screen? Irrelevant of course, of the service startup time. And again, here you see like in this specific case, we went from half a second to quarter of a second on this specific machine. So about twice as fast as it used to be. So something that's some performance improvements we are really excited about, and we will continue to do throughout the year. The next thing we'd like to talk about is .NET Core. And so for update 6, we added a previous support for .NET Core. And by update 7, we kind of finalized that and have now full support for .NET Core. So we only dig a little bit more into this a little bit more. So one thing to note about .NET Core is it's sort of like a new version of .NET Framework. It's built completely open source and it's cross-platform. And it's been around for a little while for version 1 and 2, but it's mainly been focused on stuff like ASP.NET websites and so on. So mostly for server types of things and could run on Linux and so on. With .NET Core 3 and now 3.1, there's been added support for building WPF and Windows Forms apps as well. And one thing to note though, that even though .NET Core is cross-platform, the WPF and WinForms pieces to that are desktop only, so they only work on Windows. And so same thing goes for our support. It doesn't mean that we have cross-platform support here. But what's really exciting about this is if you're working with a customer who is currently limited by updating the .NET Framework, they might be only still running on .NET 4.6.1. That means that you as a developer can't use any of the new features in .NET Framework. And you're kind of forced to be on an old version because it can be tricky to ask a customer to upgrade all their machines to the latest, greatest, because it actually affects all the .NET apps on that machine. And until you might have certified all those different apps to run on that framework, you can't just go and update this. And .NET Core solves this by actually allowing full side-by-side. So you can install .NET Core 3.1 and 3.0 and 2.1 and so on and so forth side-by-side. And any apps that are, for instance, built for .NET Core 3.0 would not be affected by you installing .NET Core 3.1 because it will still run in the 3.0 runtime. And so it gives us an ability to kind of actually pick as a developer the best platform for our application rather than worrying about what the customers have. And actually you don't even have to worry about whether your customers have .NET Core installed, because you can actually do these completely self-contained applications where .NET Core and WPF gets shipped with your app. So there is actually no dependency whatsoever on the customer's computers except just having Windows on it. One thing to note, if you do that though, if you deploy .NET Core with it, you also take the responsibility of updating .NET Core. So if there are security issues and so on, like you have to also take that on. If you install .NET Core as a separate install, this stuff will be serviced through Windows Update. But there also .NET Core adds a lot of performance improvements. Here's an example of just a benchmark we did. This is a very simple benchmark that just creates a point. And this one is actually mostly meant to like just hitting our interop, that means us calling into native code. And we're seeing about an improvement of 52% in this specific case. Like it's about twice as fast for interop calls. And while these numbers are in microseconds, so overall that probably doesn't matter too much for your app, but it does add up when you start having a lot. It can add up if you have a lot of interop heavy code. But there's also lots of other places where .NET Core is improved performance. Another thing for .NET Core is that we have a new way to actually create single file executables. So instead of having a folder full of DLLs and EXEs and images and so on, you can actually compile your app down to one single file. Just one EXE, you double click and you're up and running. And that file can also still include all of .NET Core, all of WPF, all of the ArcGIS Runtime and so far, and it's just one file. That's a pretty cool thing to do. One thing to consider, this is shipping with everything and .NET Core and Runtime as a single EXE is about 250 megabytes. So it does add a little bit of a size, but had you done, it's not really much different actually than doing a self-contained app. You also get full C#8 support. And so what that means is .NET Framework today does not have full C#8 support, which is the latest, all the latest language features. Have some of the features, but not all of them. With .NET Core, you get all of it, and that also means you're allowed to create more performant apps, or use more or better, cleaner code as well. And again, .NET Core is going to continue getting enhancements. .NET Core 3.1's next version is actually called .NET 5. They're skipping forward to avoid confusion with .NET Framework, but it's essentially the next version that we expect in November 2020. It'll also provide ahead of time compilation that increases your startup time and so on. But why would you use .NET Core? Like, should I move my app to .NET Core? And one thing to consider is that .NET Framework 4.8, which is the latest version, is also the last version of .NET Framework. It does not mean that it's out of support or anything. It will be supported as long as Windows is supported. So it's not going anywhere, but it's also not going anywhere in the sense that you're not getting anything really new. You'll still submit security, you'll get security fixes and critical bug fixes. But it's kind of like almost parked at like just a maintenance mode at this point. And you'll already see that .NET Core has several features that you just don't have in the .NET Framework. And here's a quote from Microsoft themselves that is saying, like, if you have an app on .NET Framework, continue using it. It's fine. We fully support you. But if you build a new app, please consider using .NET Core. This is where things are going. You might also want to consider moving your existing app to .NET Core if you're planning on maintaining this app and expanding on it for a long time. And so you can get all those latest improvements. Another thing I actually really like about .NET Core is that it's fully open source. And that actually allows you to use a feature called source linking, that so the symbols that you get has actually reference straight to the code on GitHub. And so if you want to step into the code, it'll actually dynamically download that code from GitHub, and you can better understand how .NET Core is working and understand why your app is running. It's something that we have had a lot of benefit of, to better understand like why our code not behaving the way we expect it to behave, and we can kind of better understand, well, what caused it to behave this way in the underlying framework of .NET or WPF. We also see that because it's open source, they take community contributions, and the last thing I heard, I believe the number of contributions from the community was about 30% of everything that's going into .NET Core, so it's very rapidly developing that way. And so a smaller bug that is maybe not important, the highest priority for Microsoft to fix, might be important for a specific customer, and they might go and make that fix and take the time to do that. So it's very, very exciting. But what if I do want to move my app? It's like I have a .NET Framework app and I'm maintaining this for a long time, and I want to get some of these cool new features, or maybe there's some ability to improve performance. So one thing you can do to start with is you can go to the marketplace and install this thing called the .NET Portability Analyzer, and that'll give you an idea of how easy it's going to be to port your app to .NET Core. That's the first step you would be doing. And so when you do that, you actually get this little context menu on your project that you can say Analyze Project Portability, and it'll give you a little report. You can also do this API port tool, and this is more of a command line tool, and you can run against an already compiled app and analyze all the DLLs and the EXEs in your app, and basically give you a similar report for whether your app is easily portable to .NET Core. Here's an example of such a report that I ran against a specific app, and most of those APIs are typically supported, but in this specific case, for instance, stuff like the geocoordinate watcher we use for getting GPS locations was not supported. And the reason for that was actually it's based around some deprecated Windows APIs for getting location. And this is something that the runtime actually hit that we were trying to move. You can actually see in the column that it says that the ArcGIS Runtime DLL is the one that had that problem. So we had to, of course, to support .NET Core, we had to actually change our location display to use some newer location APIs. So you might hit a little bit of this, where there's a little bit of work involved in porting. But for the most part, we're finding most things working. Again, for the runtime, this was actually really the only big thing we hit. It was this thing, and we're using some old web request APIs that have been cleaned up. So there's typically other new APIs that are better to use for that scenario. Another thing you can start considering doing now is if you have class libraries, make those class libraries use .NET Standard. We do support .NET Standard with the runtime as well. So anything non-UI is fully .NET Standard compatible. And so the more of you do that, the easier it's going to be to move. And a side benefit for having some of your business logic in .NET Standard libraries is you also get to use it with our Xamarin offering. So you can build Xamarin apps and reuse some of your business logic in your iOS and Android apps, which is a really neat feature to have. I want to call out a little link to this this blog post here. We'll really talk about how to do some of those things to do a port of your app. So we're going to talk a little bit about, do a little demo of this. So I have a little app right here, and this is a typical .NET Framework app. There's nothing special about it. If I look at the project file, here's the raw project file. You've probably seen something like this. It's a lot of gunk of all sorts of stuff, information here that's kind of hard to maintain. You typically would maintain this inside Visual Studio instead. But you can see that it's a .NET 4.7.2 app in this case. And so the first thing I want to do is I want to see, can I actually port this app? So I would just right-click and say portability, analyze portability, and this will actually then analyze everything that my app is using and generate myself a little Excel report that I can open here. And this will give us an idea how what problems we might hit. And so in this case, it's actually saying that .NET Core plus Platform Extension is 100% compatible, and .NET Core, this actually means .NET Core 3.1, it's a little misleading name, is also 100% compatible without the platform extensions. And I'm a little over 80% compatible with .NET Standard, which is okay because I didn't plan on moving to .NET Standard, but it does tell me that maybe I should consider moving 80% of my code into a .NET Standard class library. I didn't get some details in here. What was it that was not supported in .NET Standard? So typically this is, if you look at all these APIs, it's calling out, these are WPF APIs, which are not supported by .NET Standard. But you see, for instance, that .NET Core 3.1 Plus is fully supported. .NET Core 3.0 plus Platform Extension for 3.0 is also fully supported. At this point, 3.0 is actually not even in support anymore. So really just focus on the 3.1, and that's also what we require with the runtime. So what would it take to actually port this app? And there's a little command line tool we can use. And it's called try convert. And I've installed this as a .NET tool, and I'll have that on the slide how to install it. But I'll basically say try convert. And I'll say project, will be my map app. And I'll basically hit enter. And it's going to go through and actually basically mainly just touch my project file. And so if I go back here, it should say you want to reload. Yep. And at this point, hopefully my app will be a .NET Core app. And I can actually now right-click here and say edit project file, which you cannot do with a .NET Framework project. You can actually edit it here live and not having to reload your whole project. So here's the new project file, which is much more succinct. I actually know for a fact that I actually don't need these. The try convert does the best guess. I do have to know that this actually converts by default to .NET Core 3.0, and as we require 3.1, I'm going to move to 3.0. So you might see here there's a little warning, but if I hit save, this should hopefully go away in just a sec. See, at that point, it's like, okay, now we're fully compatible. And I should now be able to run my app as .NET Core. And that is really all that was required. Of course, I was lucky in this case. I didn't hit any APIs that wasn't supported. But I'm generally finding it hasn't been much issue. And so here the app is running. And one thing I want to show you is that I put a breakpoint right here. And I can see all this SAML stuff here. So what I can do is maybe I want to load these symbols. So I hit right-click this system SAML one and understand why did this get here. And now I can double-click any of these methods. And when I double-click, I say, hey, do you want to go download the source and debug this? And it pulls it right from GitHub. And this is what I was talking about earlier. Like because it's open source, I can now actually see the code that was used to generate. This is not decompiled code. This is the actual code that was used to compile. And it's pulled straight from GitHub on demand, so I can start stepping through. And I click another one, it's going to ask me again. A really cool feature that I really love having able to do. All right, I'll just continue to run. And I should hopefully just have my app running on .NET Core, like that. So another thing I can do for a .NET Core app is I can publish it, and if I right-click publish, which is also a slightly new feature, it'll take me through this publish workflow. So I'm going to create a 3.1 profile here. And so I can go and change some of these settings. So first, I want to do a release, of course. A targeted .NET Core app, of course, but then the deployment mode is sort of interesting. So if I have .NET Core installed on my users' machines, I will just pick framework dependent, and it will just deploy what the app is and rely on .NET Core it's already installed. But I can also show self-contained. And so what self-contained is going to do is take all of .NET Core that is needed, and WPF as well, and copy it all to the output folder of the publish folder. I can choose with architecture. In this case, only these two will work because I'm using WPF, so I can't really use the other ones at this point. But I also get a few more options here. I was talking about how you can make a single exe, and you do that right here. You basically check that one, and it takes everything and compiles it into a single, I think in this case, 250 megabyte file. Of course, if I don't do self-contained, it's a lot smaller. I can enable ready to run, which is actually based on pre-jitting, so should improve your startup time significantly. And there's also a preview feature here that trims your assemblies. And what it basically does is that the compiler tries to figure out which assemblies are you using, which assemblies are you not using, and then tries to strip out anything that is not in use. It might make a mistake. I have not seen it do that yet, but that's probably why it says in preview. So of course, test your app really thoroughly that it didn't. But in my test case, this typically cuts a good 60 megabytes off your deployment. So a really neat feature. So I'm not going to do this here because this takes it takes a few minutes to run this whole publication, especially if you do linking, ready to run and produce, it adds to the time. But what I do want to cover is a slightly different way of deploying your apps. So I want to cover a new type of project. And so when I want to deploy my app, one of the things I often struggle with is how do I get this app installed on my machines and how do I update it? And for those of us who used to work with a lot of Silverlight, one of the great things is you went to the website and the app was always up to date because that was that single place it was built against. And with the new Windows Application Packaging project, you can actually get some of those same features. So I'm going to create this project. I'm going to call it maybe my map app. And I'm going to, this is also referred to as MSIX. You're probably familiar with MSI installers. So MSIX is sort of an evolution of that. And so it creates this new project, and I'm just going to add my application to that. So I'm going to basically add a reference to it. And that means that this installer should be installing that application. Get a package manifest where I can set all my app icons, app names, and so on and so forth. But I can also go to publish here, and I can create app packages. And for those of you who have done a UDP app, you're actually probably already familiar with the app manifest and the publishing. But it's actually, so it's a very, very similar workflow that you get with MSIX. But in this case, I'm doing a .NET Core app. This, however, does also work with .NET Framework. But so here I get to have to do a Microsoft Store app. If I'm planning on putting this in Store, I can create a Store app, or I can create side loading. And I want to call out your attention to the enable automatic updates. It's a really nice little feature that you get with more recent versions of Windows. Another thing we have to do is we actually have to code sign these applications. If you don't code sign, you get kind of a warning, and it might make it a little tricky for your users to actually install these apps. So the best thing is also get a code signing certificate to sign your apps, but again, we should always be signing our apps anyway, right? So now we can guarantee that this app was built by me. And so here's where my app's going to be. I'm just going to copy this location for use in a minute, and maybe I want to build just a 32-bit release. I can do both if I wanted, and then you can just install the actual specific application. But this will install a self-contained app for you. And so the next point is, because I chose to have auto update installed, I can actually say, I'm planning to publish this app on maybe my server.com/apps. And so the app can then say, every time the app runs, check that location and see if there's a new version available. I can also change it to like check every hour, for instance, or so on. I can also just, if I'm on an internet and it's just for internal use, I might want to set a website up. I can really just say like map server/apps/something, wherever your app's going to be. And so you can also do it as a network share for internal use, which is also a neat way to deploy and update your apps. Lastly, I can actually just put it in the folder where the publish is going to happen, so the app's going to go there, and I can create. However, in the interest of time, again, this is going to take a few minutes. I basically already clicked the create button, and the output actually comes something like this. Here's my app that I installed, and here's the app installer. If I double click this, the app will install. There's also an HTML file that you can put on your website. So it looks something like this, and again, you basically just click get the app. Of course, you can change what this looks like if you want to change the layout a little bit. But this is going to create this installer experience. And it's even a trusted app because I signed it. And so I'm going to click install. And what this app's going to do is just install it in a single location. And something that's really special about these apps, they're sort of virtualized in where they're being put and what they can do to your system. So let's say this app makes writes to your registry. It's something that can kind of really mess up your system. And so it can read anything from the registry that this app's allowed to read from. But if you write to it, it's actually written to an overlay. So any writes would actually not go into the real registry, and it would go into sort of like a fake overlay that just this app reads in. So it can't actually mess any other apps up. So it's very secure. So here's my app running. And I'll actually get a nice little new app icon. It's called My Mapper. I might want to change my icon. It's not the prettiest one, but that's the default you get. And so if I were to go here, I'm going to right-click this, and I hit uninstall, this app will remove anything it did to the registry, anything it tried to write to like your Windows folder, which it probably shouldn't be doing, but if it did, it won't mess that up. So it's safe to uninstall. I've heard of cases where companies are not allowed to uninstall any app because it could risk breaking other apps because they remove some shared component. So this actually solves this solution, this problem. But let's say I want a new version. I didn't really like the base map, so I kind of prepared a new compilation, a version 1.0.1, and I'm just going to copy that to my update location. So imagine that I just built the app and I published it again to my location, to that folder. And so because I set the app to update every time I run the app, so now I'm clicking on run this app, the app's going to go and check that location. It's like, hey, do you have any updates? And you might notice that the map doesn't actually look any different. It's still the light gray base map. But at this point, it knows that the app now has updates. So if I do it one more time, and I want you to pay really close attention to right under the My Map app, what's going to happen when I click it. You're going to see a little progress bar right there, real quick, and it just updated. The only thing I did was to copy the new version into that folder, and the app automatically did it. So you just put that update on your website or on your internet server, and you can instantly have everyone in your organization have the new version. And again, you can set it to just update every hour instead of every time you run. But it provides this really neat way of updating apps to with your customers. So I can really, really recommend doing something like that. So, just a few resources I want to share. Again, there was a .NET Portability Analyzer. There's a little shortcut link here to it, but you can also find that in the marketplace. I used that try convert tool. It's a .NET tool, so you would go in a command line and basically just write .NET tool install -g try convert. And after that, you get this try convert command line tool. Again, there is this link to this blog post I want to recommend you read that will talk more about how you port your apps to .NET Core from .NET Framework. And I also want to call out this special session that was recently published on YouTube, and it really talks much more about modernizing your apps by moving to .NET Core, doing this packaging, go much more into detail in that, and as well as building like your continuous integration. It's a really great session to learn if you're more interested in some of those things.
Excellent. So we've just talked about some really great enhancements that we've made specifically to the .NET SDK over the last year. We took a look at the Toolkit, specifically the 107 release, and including the new documentation site for the Toolkit. We took a look at performance improvements that we've made to the .NET APIs, and we just took a look at .NET Core support with WPF API. Next, we'd like to move on to a topic that applies across all of the ArcGIS Runtime SDKs, but we felt it was a really underused and under-recognized new aspect of the API that we've been working on over the last year, not just in the runtime, but actually across ArcGIS. And that is the area of advanced symbology. So what do we mean when we talk about advanced symbology? Well, really it's just the symbology model for ArcGIS, but it's more advanced than, say, picture marker symbols that you might be using today with the API. And all of this symbology is based on the cartographic information model, also known as SIM. So this is a public publish specification for content, cartographic content, that is used to persist, so save and transfer these cartographic descriptions. We talk about cartographic descriptions because it refers to maps, to layers, and to symbols. And so specifically we want to talk about symbols today. But it's important to remember it works across the ArcGIS platform, whether you're using Runtime, ArcGIS Pro, or you're using services, or even the JavaScript API. And it's represented as JSON, and you'll see some examples of that as we go through the next section of the session. So I mentioned symbols based on this cartographic information model. So I'll talk about SIM symbols. And these symbols are contained within style files. So style files are a database of symbols that allow you to store, manage, and share collections of these styles. ArcGIS Pro allows you to create styles, and ArcGIS Runtime can consume these styles. The symbols are composed from one or more symbol layers, and each symbol layer has visual properties and it has geometry. So the key about the symbol layer having geometry and the symbol having geometry is that we can vectorize the rendering of that, which means we get really beautiful, crisp rendering of the symbols on any device at any resolution. The Runtime API contains API types for working with these new symbol layers. So I mentioned the multi-layer symbol type on the slide there. There's a range of API types under that area for working with different types of symbol layers. And one way to think about this is the replacement for the composite symbol. So for example, in the past, where people have tried to display some text with a circular background, perhaps, they've used the composite symbol to provide a marker symbol of a specific size and then a text symbol as part of that, and assign that single symbol to a graphic or a feature. And the multi-layer symbol approach is really the replacement for composite symbols. And the nice thing, as I said, about the multi-layer symbol approach is that it works across the ArcGIS platform. Composite symbol was something that was only available in ArcGIS Runtime. There's another note on the slide there that these concepts support the dictionary renderer. So that's really an advanced version of the sim and the style file and the symbols that are in there. Dictionary renderer contains additional logic that allows you to assemble individual symbol layers into one of these multi-layer symbols that are specific to a set of criteria. So now let's take a look at a demonstration of creating a symbol style picker with ArcGIS Runtime. But first, we're going to start off in ArcGIS Pro. So to provide you some context for the demonstration, we're going to start in ArcGIS Pro here. So I've got a relatively empty project. I've just got one layer within my project, and it's currently symbolized with the default Symbology when I added this shapefile to ArcGIS Pro here. If I right-click and go to on the context menu, choose Symbology, instead of this default marker symbol, on the symbol dialog, I can see a number of different symbol options that I can choose from. Crucially, these are from the ArcGIS 2D style in ArcGIS Pro. And I could obviously apply one of these styles to that. So where is this style in ArcGIS Pro? Well, if I switch to the catalog pane, under the styles here, we can see the ArcGIS 2D style in ArcGIS Pro. And if I right click and manage that style, we can see that same list of styles here. And looking at the square that I applied to my cities there, on the right hand side, once I've selected that, you start to see some of the properties for this. If I switch to the properties tab, we can see the appearance, and if I select the layers, actually you can see that this single symbol is comprised of two of these symbol layers. So there's the red background, and then there's the black outline and the central marker. So these are symbols within a style in ArcGIS Pro. How would I get those to ArcGIS Runtime? Well, what I can do is in my style item in the catalog window here, I'll choose new and then new mobile style. So here I'm going to create a new style called Mike. I've already got one that's called Morton there. So within my Mike style, if I manage that style, currently it's empty, it's a brand new mobile style. If I switch back to my ArcGIS 2D style within ArcGIS Pro and select all of those symbols, right click and copy, and then I'm just going to paste those into a Mike style. And I'll accept that in some cases there may be some subtle differences between ArcGIS Pro and ArcGIS Runtime, and there may be some subtle aspects that are downgraded during that transfer, but you can see it's pasted in all 266 symbols from the ArcGIS 2D style in ArcGIS Pro to my ArcGIS Runtime mobile style. And I'll now share that with my colleague Morton, and he can continue the demonstration.
Right, so I have a little project here, and I renamed his Mike style into something a little more meaningful for my scenario. Sorry, Mike. But it's basically just the same file, and I just added this as content to my existing app. And I like to try and use this. So I have this very simple app. It has like a feature layer with a symbol renderer and just a base map. So the first thing I want to do is actually try and load this. I'm just going to paste a little bit of code in here. And I'll walk through this real quick. So I have this load symbol method, which is going to load all my symbols. So in my constructor, I'm just going to make sure that happens. And so it basically just points to that file that I just have in my Solution Explorer. And the first thing I'm going to do is, from that style, I'm going to just get the default search parameters. And so these search parameters, if I don't modify these, it basically going to give me every single symbol in my symbol style. And so I'm just going to search it with that, basically these query parameters. And I'm going to get this collection of symbols that I assigned to this little list I have here of symbol style search results. And I'm just going to raise a property change notification that I changed it so my UI would realize, hey, there's new symbols available. I should probably refresh my view. I also add a little selected property, select a symbol property. So if I want to select a symbol, I could then set this value, and then if I chose a value, set the renderer symbol that I have in my feature layer to that symbol. And so I'm just going to switch to my view here, where I already set up my view with 2 columns. So I'm going to, in the first column here, I'm just going to add a little bit of XAML. And so here's just a list view. And the list view binds to that collection of symbols that I just defined. And also have a selected item that sets the selected symbol. And this is 2 ways, so it goes back, and if I select something on the list view by clicking it, it goes and sets it on my view model, that then sets it on the renderer, and hopefully my map will update. For each symbol, I'm going to render the name. So I know the search result has a name property, so I'm going to bind that. And I'm also going to use a little control. This is actually from the toolkit that we talked about earlier. And it has a nice little control that just takes a symbol and allows me to render like a rasterized version of that symbol so I can see what does it look like. And so consider it more like an image control that takes a symbol and then renders it. Okay, so I'm going to run this sample real quick. And while it's compiling, it's going to start up, and hopefully we will see my map with my feature layer with my beautiful red dots. But now I also have all these symbols right here. And you might recognize some of these symbols. Here is the one that Mike was using earlier. It's the exact same symbol, so I can now change the different symbols. In fact, let me go over in my selected symbol and just set a breakpoint right here and click one of those. And you now see there is a value, which is the search result. And it has a name, that was a key, and it has a category called shapes. There's the symbol itself, and you can say it's a multi-layer point symbol, and there's also some tags. It's black and red. So this tells me various information about the symbol, and I can actually use some of this to search. And I actually think this category is quite interesting because my list, I feel like, is kind of big. It's a lot of symbols to try and find. So I'm going to try and refine this a little bit. And so for my next little magic trick here, I'm going to change this little bit of code. I'm just going to delete this and load my symbols a little bit differently. So I'm going to just paste a new bit of code, and it's basically the same method. So again, I'm still doing the OpenAsync. I'm getting the search parameters. But in this case, I'm just going to get the categories from parameters. And so when I get these default search parameters, this property is basically a list of strings that represents all the categories that are available in my style. And I'm going to assign this to this property I have. Again, notify my view model that I have changed. And then I have a new property called select a category. And so I'm just going to set that to the first category that I got back. So in my selected property, I basically just set that, raise notify change, but I'm also going to initiate a load of that category. And so this code is essentially identical to what we had first for finding all the symbols. But in this case, I'm getting the default parameters. I'm going to clear all the categories because I don't want all the categories back. And then I'm just going to add that one category that I selected. And then this is actually the exact same code. I'm going to select the symbols and just raise that property changed. So the only thing that's left to do is to add a little combo box. So I'm going to, here I already set this up for 2 rows. So I'm just going to paste in a little combo box, and this combo box is just going to bind to all the categories. And again, the selected item just binds back to the selected category. This is a 2-way binding, and with a little luck, I will now have a category picker as well. So now we see a combo box here, and it says shape, and this list is a lot shorter. And now I can pick a different category, and it's going to trigger that code, set in the category, load the symbols for just that category, and you see them right here. And then I can pick different symbols. So let's say, for instance, let me set a breakpoint here. Let's take a little bit closer look at this symbol, and let's say I'm going to pick this campground, which is basically kind of a gray circle white background with a green tent. And so if I go and inspect this, do a quick watch and open it. So here again, my campground symbol. And let's drill into the symbol and see what's in here. So you see it has a color which appears to look like something that's green. That sounds about right. It has a size, it has some rotation and stuff, but you also see those symbol layers that Mike also showed in Pro is actually represented right here. And there's 2 layers, so that's probably my circle and my tent. And so drilling in more, I can start seeing stuff like another symbol here that's a marker symbol elements. It has a vector marker symbol element, so it's a whole geometry model. And actually, here's the geometry. That is most likely just a circle that it represents. You also see something like is color locked. And I'll get back to that in a minute, but that kind of controls whether this color up here on the actual symbol applies to the layers below. So if it's not color locked, this color would kind of force its way through all the sub-layers. So if I go to a different layer, like if I go to the tent, which I'm assuming it's a tent, you see this color locked false, which means that if I were to change this color up here, it would apply to colors down below here. So it gives you an easy way to actually just change the color of some of the symbol, but not all of it. But of course, you can also change the color at each symbol level. So this got me an idea. If I can create symbols like this, and there's a whole object model, I don't necessarily have to use Pro. Pro is a great way for creating a set of symbols like this to have as kind of a set of resources for your app. But you might want to be doing things more dynamically on the fly in your app. So I created a new app, what I call the symbol editor, and I just see like how much can I actually edit runtime, like real time. So I built this little simple app, and it basically just have, here in case there's a little class break renderer, so I can right click this, and this is using the table of contents control right from the toolkit, and I'm just going to view the symbology. And so here's it's a unique values renderer, and let's say I want to change the red one here, I want to look at that one. And so here is basically my symbol. You see there's a red and a white, that's the 2 layers. And I have the symbol right here. And this is actually a nice little trick. I'm using the map view control to do this. Just rendering a simple feature, and I turned on reference scale, so when I zoom in, the feature also zooms and gets nice and crisp. And you see, even when I zoom in this much, it's still nice and crisp. It doesn't get blurry at all. Of course, I can change the size right here. I can maybe rotate it a little bit. I can also drill into these layers. And so let's say I change the color here to blue. Nothing actually happens. So the way to do that is I will go into this thing, and you actually notice that this layer is color locked. So I'm just going to change that, and I believe if I even go further down, there's more color locking. I'm going to turn all that color locking off. And now if I set the color, it should change. So now I can actually get just this simple property to change my symbology. Here's the house. Maybe I want to make that a little bit bigger, smaller. Maybe I want to, because it's kind of a damaged house, maybe I want to tilt it a little bit, because it looks like it's now a destroyed house. If I really want to destroy it, I can actually go all the way into the geometry here. And so here's another little trick. This is actually a map control with a white background, and I'm using the sketch editor to allow me to freehand style my own kind of broken house. So this seems like a kind of broken house. I'm going to accept, and now here's my new symbol. So I basically just use sketch editor to draw a new polygon that I then use in my symbol. And I can accept that, and then set apply, and here's my beautiful new collection. I might want to change this one, and so I could also go and say, I want to load it from a symbol style. So here is essentially the symbol picker that I have. It seemed to actually just crash. There's probably a bug in here. But it would basically do the same symbol, the symbol layout. Oh, that was not the app. Let me try again. Not sure why that happened. So let's try and modify this one. Let's see if it'll work this time. Nope, that is still crashing. It's open source, and I'll share the source code in a minute. We can fix that. I keep opening the wrong one. I do want to show one little more feature of this little app that you might find useful. So I can right-click this, simple, and I say View JSON. So this actually gives me, basically just calls to JSON on the symbol and gives you the full JSON representation of the symbol. You'll see the marker graphics, you'll see the geometry in here. all the information, and I can copy that. I can even copy this code and go back to my app and say, actually, I want to define my symbol like that, and I actually have C# code I can use right there, and there's my symbol. And a simple way I could do is I can go and actually do search replace on some of these values and actually quickly modify a symbol on the fly just by actually modifying my JSON. So it's a quick little way to actually do much more advanced symbology and control your app more dynamically this way. All right. So again, the source code is available right here. It looks like I need to make a few improvements for a little bug right there, but you can go and download it from GitHub today. There's actually a bunch of demos in this repo that I recommend you checking out. Symbol Editor is just one of them. There's stuff like doing indoor routing and measurements and so on and so forth that I can recommend you looking at. I even published this as an MSIX, so you can, just like I showed earlier, you can actually go right here and just install the app. But I recommend you browse the source code. There's a lot of controls in there for doing symbol editing if you need something like this as well. And just to finish up, we want to talk a little bit about what we're probably going to be working on this coming year. And this is, of course, all preliminary, but we do want to give you a little heads up and something that we want to talk about. And hopefully next year at Dev Summit, you will probably see some of this in action. But the first thing we're actually working on hard, and we already started a lot of work on, is the ability to what we call nullable annotate all our API. And so what that means is there's a new C# feature, or that's part of the .NET Standard 2.1, so you'll see this in .NET Core, as well as C# 8. And it allows us to basically tell you whether we allow you to pass in a null or not. So you might have hit the thing where you get a null reference exception or argument null exception because you got a null from somewhere, and that null got sent into your code, into our code, and it didn't like it very much. So we'll be able to tell you whether we allow nulls, but also whether we will return nulls. And so this is kind of a lot of work, but here's a great example of this, how this could happen. Like you might have some written code like this, is like, it's basically assumed to a layer. I get the full extent of a layer, and I say assume to that. And that code looks great, and all my testing, this works great. And then your customer one day calls and say, hey, every time I click this assume to layer, it goes, boom, my app crashes. And you hadn't seen this in your case. But what actually really happened was that this layer didn't have a full extent. Maybe because it didn't load, there was a network issue or something. So we can actually annotate it, and if you had nullability turned on, your compiler would actually have told you, hey, you're getting something that might be null. But you're passing something that might be null into something that does not ever allow a null. And so you have a potential of crashing here. So you might know this will never be null, and you can then force that through, but it forces you to think about all these different edge cases. And so the way you would typically fix this is you would basically just add a null check. And the code analyzer in .NET is smart enough to realize, well, at this point, we already did a null check, so we know it's not going to be null and your code is fine. You might want to write your code slightly different. You might know you want to have a zoom to layer option if it's null, but it sort of forces you to have much better code quality. And so at this point, we've been doing this a lot internally in our internal source code. And we are starting to do this on the public APIs. It's going to be a long process. There's a lot of APIs for us to annotate, so it's going to probably take us all year. So in the next few releases, you might start seeing nullable annotations in our APIs. If you were to turn this on in your app, you might see some of it. It is not complete. It's not. You would consider that preview. Like, go with the journey with us. It's going to take us a while, and it's going to take a while for all the other class libraries out there you might be using to do the same thing. And it's not really super useful until all your dependencies actually supports it. So .NET Core has this full support, but maybe not other class libraries you might be using has it. So this is a work in progress. We are finding so far, we are finding weird edge cases we never thought about could happen. And so it is improving our internal source code, and you would already see the benefit of that in update 8, that we should see more stable just because of this. Is pointing out edge cases that hasn't been thought about. And then the same thing will be for you. That will probably help that. Later this year, we expect .NET 5 to be shipped, and this is a very, very exciting announcement for us. What that means, it's going to take Mono that we use for Xamarin, iOS and Android. It's going to take .NET Core, and also in the future, hopefully the UWP platform, and they're all going to be running on the same version of .NET. It's not all these different flavors that might behave and act slightly different. It is just one .NET, and is referred to as .NET 5. One way to think of .NET 5 is the next version of .NET Core 3.1 plus a lot of the stuff that Mono has to offer merge into one new framework. So this is very exciting, and it's something that we hope to be able to support hopefully shortly after it ships. Actually, at this point, we don't even see a reason why the current update 7 wouldn't work on it, but it's definitely something we're tracking. But until we actually have it in our hands, we might not be able to fully support it yet. But I hope that's something we definitely are tracking right now. Another thing we find really interesting that's coming this year is this concept of a new WinUI API. And so this is basically the UI framework that is in UWP. Personally, I really like that API. I feel like it's a much more cleaned up version of WPF. It's much more performant. It also is better for your memory on your devices. So if you have people on tablets out in the field, like the best memory or battery performance you can get can be really important. But UWP has this slight disadvantage, is that it also runs in a sandbox. And that's actually an advantage in many cases, but for some people it might not be. But it also means if you want to use the latest version of UWP, again, you're requiring your users to be on the latest version of Windows. And so WinUI is taking the entire UI framework of UWP and pulling it out of Windows and be independent of which version of Windows you're running, as long as it's Windows 10, but it doesn't have to be a specific version of Windows 10. But it also allows you to run it on top of .NET Core as a Win32 app and not as a sandbox app. So you get to choose where you want to put it. So it's something that looks like to be the future of UI and Windows in general. One thing to consider, WPF is 15 or 20 years old at this point and is based on a much older DirectX technology. So this is very exciting for us. We're also looking at adding support for Metal in iOS. That's OpenGL is essentially deprecated on iOS, so we're working on that towards this year, and hopefully later this year we'll fully support Metal on iOS as well with our Xamarin SDKs. So that's some of the stuff will keep us busy for this coming year. And with that, we're pretty much going to end it. We encourage you to just continue discussion on GeoNet and post any questions there, or even on Twitter. Definitely, I'm pretty active there if you want to reach out, but the GeoNet is also a great place to post your questions. Check out the Toolkit, the GitHub, post your bugs there as well if it's specific to those. The entire team is trying to be very active in both on GeoNet, on Stack Overflow, and on GitHub as well. So.
Yep. And with that, we'll wrap up the session. Thank you very much for listening. There's also a note there about another recommended session that is really a partner to this session. So today we've talked about building Windows apps. This session talks about building Xamarin apps for Android and iOS with the .NET SDK. Thank you very much.
Thank you.